A good evening to you and welcome to my today's class in mathematics. And I have a question here from the laws of indices that I want us to look at and be able to get the answer to the question and be able to see what was behind the examiner's intention of bringing this question. So I'll first be able to copy the question down, then be able to head to the working for us to get the answer. So the question reads 27 raised to x minus 1 multiply by 9 raised to x, the answer must be equal to 81 raised to x. So this question has actually been able to get brought to our attention from a topic called the laws of indices. And for us to proceed forward and do this question, we are supposed first to ask ourselves, what are we supposed to do? We need to apply the laws of indices, and these laws demand that anything that has to get worked out in as far as this area is concerned must first be able to consider writing each and every base to the lowest form. And for example, we have our base here as 27, our base here is 9, and our base here is 81. We are supposed to rewrite those bases such that they are to the lowest form. And the lowest forms of these bases is 3, because I don't think 2 can go into 27 a particular number of times without leaving a remainder. And that means the only number, the lowest value, a numeral, a digit, that can get used as the base, and of course which can go into these 3 digits without leaving any remainder, is 3. So we can rewrite 27 to base 3, rewrite 9 to base 3, rewrite 81 to base 3. Why? 3 is a common divisor, and it is the smallest number that can actually be able to go into 27, 9, and 81 without leaving any remainder. So for us to come up with those bases, we are supposed to use what we call the factorization method. And you're going to get the prime factors of 27, the prime factors of 9, and the prime factors of 81. I'll start. We have 27. What are the factors? So I'll have 3 into 27, because the first digit that can go into 27 is 3. So we shall have 9, and again 3 into 9, 3, and again 3 into 3, 1. So I have 3 into 27, 9. 3 into 9, 3. 3 into 3, 1. Look at that. So that translates into our base being 3, because I've told you we need to change 27, 9, and 81 to base 3. So our lowest base must be 3. So our question should be, how many times should 3 be able to get multiplied with itself for us to get 27? You have 1, 2, and 3. So that means 3 times should give you 27. 3 times should give you 27. 3 times 3 times 3 should give you 27. So that should be into x minus 1. Close the brackets, multiply by. We need to again change 9 to base 3. How? Let's come here. So we have 9, that goes to 3 into 9, 3, 3 into 3, 1. So that means 3 is our new base from 9, being our initial base, can be able to get raised to 2 for us to get 9. That means 3 into 9, 3. 3 into 3, 1. So 3 2 times can give us 9. Then our power is x. That should be equal to, let's get to 81. So we want to see, 81 is 3 raised to which base? Correct. So 3 here, that is 27. 3 here, that is 9. 3 here, that is 3. 3 here, that is 1. So 3 raised to something should give us 81. That is 1, 2, 3, 4. So 3 raised to 4 is equivalent to 81. Our power is x. We can rewrite everything ensuring that the powers are actually multiplied to open the brackets for us to actually proceed with the working. So I'm going to have 3 raised to 3 times x, that gives us 3x, minus 3 times 1, that gives us 3. Then you multiply this by 3 raised to 2 times x, that gives us 2x. That should be equivalent to 3, then raised to 4 times x, that gives us 4x. After I have known that the bases are the same, of which 27, 9, and 81 are all written to the same base, which is 3, I can be able to combine two bases on one side of the equal sign if they tend to appear. For example, we have this and this. So the bases are the same. I only pick one base. I'll pick this first power. I'll write 3x minus 3. Then multiplication, in as far as laws of indices are concerned, will change to addition when two bases are combined. For example, someone can come here and say a raised to m times a raised to n. I know the bases are the same. I just pick one base, which is n. Then the first power is m. Multiplication sign changes to addition, and the second power is n. So I'm going to apply the same concept here. So then I'll actually be able to say 3 raised to, because the first base is 3, the second base is 3. Instead of picking the two bases, I only pick one base, that is 3. So if I pick the base 3, then I actually pick the first power, which is 3x minus 3. I'll write it down. Then multiplication will change to addition. The second power is 2x. Then that must be equal to 3 raised to 4x. After I'm done with that, I'll drop these bases. Next, I'll come here and say 3x minus 3 plus 2x. The answer must be equal to 4x. Nice. Then next, I'll actually collect like terms 3x and 2x. So I'll come here and say 3x plus 2x. 3x plus 2x. Then minus 3. The answer is equal to 4x. Next, I'll have 5x. How? 3x plus 2x. Minus 3, the answer is equal to 4x. I'll further collect like terms. I'll take minus 3 on this side, then take 4x on this other side. So I'll have 5x, okay? This is 4x, which means it is actually positive. It becomes minus 4x is equal to, this is negative 3. On crossing the equal sign, it becomes positive 3. Then so 5x minus 4x, that gives us x, and our answer is 3.